Okay, so I think we're gone live. We have a good number of people in attendance. So welcome to today's session. It's Wanted, Dead or Alive. It's a Wild West themed Hunt the Malicious package. So we're focusing on software dependencies, AI, a bunch of different topics, but it should be a bit of fun. So it says 90 minutes in the top right corner. Honestly, you can take as much time as you want. The labs day. You can go back to the lab later if you want. Yeah, just do this whatever way you want. If you are the fastest person to complete all the tasks successfully, you could be in for a potential prize at the end. So stick around for that. So we'll move on to the next slide. So yeah, for the people attending today's session, if you want to start spinning up your lab and taking part, all you need is honestly a browser. You're probably already watching this in a browser right now. A laptop, really, it can be any kind of computer. It can be a Raspberry Pi that runs a browser. That's all good. As long as you have internet access, that's the fundamental basic requirement here. So the link is there. I've also put in the chat on the stage. Please message into the chat if you cannot see that link. But the link is cloudsmith.instruct.com/pages/CTF-malicious-package. So that's our link for today's session. Again, if there's any issue with the lab spinning up, just let us know. But generally speaking, they should all work. The other thing I'd point out is we're keeping these labs live long after this competition ends. So if you want to come back to the activity this evening, maybe you're watching this recording in after the event, and which is great, and you want to do this in 2-3 days time, we'll keep it live. So that's all good. We'll move on to the next tab. So so this is our agenda. We've put together, I wouldn't say it was our easiest to capture the flag activity, but it's certainly not our hardest. So it's 4 kind of straightforward enough tasks. The first one is we're going to use an open source vulnerability. That's the technology. They have OSV, the database, have their associated scanner technology called OSV Scanner. So the first task is you're really just going to download OSV Scanner. You're going to scan things like lock files and these kind of TOML files. So, one file that defines all your software dependencies and try to find, malicious code inside it. So we're trying to find the bad guy inside all that list of legitimate, trusted open source software dependencies. The second task then is we're going to take it a step further and we're going to look at what is slopsquatting, which is, look, we're all doing it today. We're generating code at crazy pace. We're using Cursor, Claude Code, you name it, Gemini. It doesn't really matter what you're using. But there's a tendency that AI makes mistakes. It hallucinates, it fabricates some of these package names. And what we're trying to do is use tools like SlopGate to be able to identify, can we find examples of fabricated package names? This can be scary for one of 2 reasons. One is the less scary scenario, which is our app just doesn't do anything because it's trying to pull something that doesn't exist. But the worst scenario is, what if it recommends a package that is known to be bad, a malicious package? And that is a very real scenario, and we'll categorize that as sort of typosquatting, slopsquatting. It really doesn't matter this time, but we need to identify fabricated package names or bad package names. Again, as part of that progress, we're going to go on to SBOMs, the traditional way of actually categorizing what exists inside your application stack. So what are all the software dependencies? Which ones are good, which ones are bad, what versions, all that kind of stuff. The history of those dependencies, you want to map it all together in a bill of material. But nowadays with AI models, we now have AI-BOMs, and I'm sure Amir and Manfred will give some great explanations in a while of why all this technology is so useful. We'll top all this off with agent skills. You're probably hearing everyone talking about skills today, which is the idea that I have an agent, the agent needs instructions to do things, and what exactly are those instructions in those skill files? At the end of the day, they're just text files, markdown files, but are the instructions good instructions? And we're going to be able to identify something bad within those. So that's today's agenda. By now, most people should be already spinning up in their environments, which is really exciting. We'll just move on to the next slide, and I'm actually going to have my other presenters introduce themselves. So we'll start with you, Amir.
Thank you so much. Everyone, great to meet you all. My name is Amir Shahmiri. I'm one of the senior sales engineers here at Mend. Mend is an application security company, so traditionally worked in sort of the SCA SaaS space back in the day. But as AI is taking over the world slowly but surely, we're making large impacts in AI-powered applications and making sure those are safe and secure as well. So very excited for today. Looking forward to getting the lab off the ground and seeing some interaction with yourselves. Manfred, over to you.
Hi, everyone. I don't whistle, so I can't do some Western Italo whistle. something. So I'm just going to keep it simple. My name is Manfred Moser. I'm a DevRel engineer at Chainguard. We are the safe source of open source. So what we do is we provide rebuilt binaries, SBOMs, so the software bill of materials, provenance data for all sorts of artifacts, lots and lots of containers, libraries, also agent skills and more. So it's always fun to hang out and do these hack workshops with Nigel. So let's go hunt those packages.
Yeah, absolutely. And again, I don't know the first thing about the Wild West, so bear with me if all the terminology is wrong. So yeah, let's start by sharing my screen. So that's the first thing I need to figure out is how do I screen share? Okay, so we have a desk open. Does anyone
Posted
know
the
where
link
that
in the
button
chat.
is?
Also, some people are still looking for the chat, so we posted it on.
Okay, perfect. So look, I'm sharing my screen now. What everyone should see when they go into the activity link is something like this. Again, go into the chat and tell me if you're struggling to get to this page. But the landing page, play.instruct.com, you should see something like maybe a little window that the environment's spinning up. These were all set as hot starts, so they should have already hot loaded before we joined the session. See the way mine says start, that it's ready to go. You just have to click on that to, when you're ready to go. So I'm going to do that. So I'm going to click start. Everyone should be seeing what I'm seeing. So far, so good. So the first task we mentioned there was finding a malicious package in something like a lock file. So we start off with the story, howdy sheriff, looks like you're tracking down some nasty outlaws. So, we're trying to use that analogy that there are bad people, the outlaws, in the Wild West analogy, and apply that to our software stack. So the first thing we can do is there are a bunch of instructions that I'm providing really as an educational foundation so you understand what this technology is. It's very hard to answer questions unless you know the surrounding context. But to complete each task, you're always going to go down to the capture flag 1, capture flag 2. There's always a flag to capture at the end of each exercise. So what we're trying to say here is with curl, I think everyone on the call probably knows what curl is, but curl is the technology for making these HTTP requests. And with curl, I can curl the osv.dev database, its own API, and check a commit hash. So with that commit hash, I can get a bunch of information from that database about advisory information. You can see it's actually quite a long response. You could alternatively, other than looking by hash, you could filter it down based on something like the package name, the unique version associated with the package, and ultimately the ecosystem is coming from. So OSV kind of sounds self-explanatory, which is open source specific vulnerabilities. So this database, it's focused on, your open source registries. JavaScript have its node package management, so NPM. There's Python has its own PyPy or Python package index. There's Maven. There's all sorts of different package repositories where you pull these software dependencies from. So in this case, I could also filter and check for that same Jinja 2 in PyPy version 2.4.1. And you can get all your information about the package to see, well, was it a good package? In this case, we're looking at common known vulnerabilities, CVEs, or GitHub security advisories, GHSA advisories that show up for it. So all this information is rich and it's quite long in what you see in return from those responses. So finding an outlaw is a little bit different than just looking for vulnerabilities, as OSV suggests. It also has this concept of malicious packages. So where a developer can write code that is, it has known flaws, these get categorized as vulnerabilities, things that can be exploited. So they're not intentionally bad, they just can be, compromised, and therefore someone can do something bad to your application. So with a malicious package, that is very different, where this is actually deliberately dangerous code injected into your application. So for instance, I'm looking at quite a long package name, but it's supply chain firewall benchmark hello. It's in the node package management, the NPM registry, and it's on version 1.10.2. Querying that, you can see this output, which is a little bit more straightforward, which is mal-year-id. So it looks a bit like how we see with CVE identifiers. In this case, it's telling us it's a malicious package ID. I'm just making the screen a little bit bigger so everyone can see that correctly. So it's saying malicious code was injected into a software dependency and a little bit of description of what that malicious code does. In general, let's treat malicious code as, there's no reason why I would allow it inside my application. So you get information
Just
about
quickly,
who
I
published.
want to point something out on that is, all this manipulation you're doing there, obviously you're not doing curl here. That's just because it's an easy command line tool. It's just public HTTP requests. So you could, any favorite scripting language you want to use, you can look at all the same data. And the other important thing is, you might be wondering, well, why is there malware on the internet? Like, why is there malware in those NPM registries? And arguably there shouldn't be. And in fact, what is the case is that typically that malware gets published by people that hack access to the public registries, and it doesn't get caught early enough by software researchers, the operators of those repositories, and so on. But also it does get yanked after a while. So those malwares are not necessarily there all the time, but they do appear. And when they appear, often they are very small windows. And in those small time windows, unfortunately, how the versioning works in JavaScript, people often use ranges, like semantic version ranges. They get pulled down a lot. So they do a lot of damage, even though arguably they shouldn't even be there.
Absolutely.
Just to add there, Nigel, as well, is that you can actually report these packages yourself as well. So if you are on NPM and you do spot one of these malware packages, click down and report it, right? Because the more people that report these and get these taken down, the less damage they can do. And it's up to the open source community to try and help the problem, right? We need to solve the problem that's out there, and we can only do that by doing our part.
Yeah, absolutely spot on from both of you. Like, I think the first thing to flag there is, again, these are old software dependencies that have most likely been removed from the registry, because this was modified or flagged back in 2025. So it's a year old, almost a year old report. So probably was taken down in the first 48 hours or so of being flagged. But also, as well as human contributions, a lot of this stuff is automated. You see things like Amazon Inspector, and these technologies are doing this sort of finding. They do this package analysis, they identify and they flag it that this is a bad package. And of course, then it gets removed from the registry. But again, there's a scenario where organizations may pull those software dependencies, cache it in their local application, and be running that for a long period of time, of which it needs to be removed. So again, it's one thing identifying it from the registry before you blindly trust and pull from the registry. Then there's also the angle of, well, you need a technology still to be able to identify what is known to be bad that you may have since cached and is no longer present in the registry. And we'll come to all this in a while. But this data is very much open infrastructure. Anyone can use this. There's no rate limiting. You can also see the GitHub links behind it that feed this information, which is, it's all structured in JSON. I don't know, it's taken a few moments for that page to load, but essentially you see it like this. It's a JSON structured page, and each record has its own JSON file with the malicious ID attached to it. So it's a pretty fantastic technology. Of course, you can play around here, filter it down by different searches, different versions. Like in the case of Axios, there was two. A lot of people might have heard of it. Some of you might not, which is Axios was a legitimate project. There was a compromise on two specific versions, 1.4.1 and 0.30.4. And in those scenarios, bad code is injected. So as well as the general security advisories, there's always going to be something like this where we say we have a malicious package identifier for that. So that was back in April of this year.
And Axios is a legitimate package, right? Like,
yes, of course. I don't mean to tell people not to use it. What I'm trying to say is, yes, in those two versions it was compromised. So that record stays there forever. But I think, Amir, are you going to add something to that?
I was just going to say, the identifier that we see on the screen now, obviously mal, it's not a consistent identifier that you see across the board, right? So if Mend finds a malicious package, or if Chainguard finds a malicious package, or another vendor finds a package, they're all different identifiers. Now, that's simply because we haven't standardized malicious packages across the entire industry, right? So the CVEs that we see for traditional vulnerabilities, it hasn't caught up to that aspect yet. So if you are saying, oh, why am I seeing mal here and I see an MSC, for example, within Mend, it's because each industry, each sort of vendor may have different identifiers that they use.
Yeah, spot on. One of the things, and for those users who might be really far ahead in the activity, they might have spotted this already, but in Skills, it's much the same idea. Skills were just created more or less this year. Was it this year? End of last year? So it's such a new technology. The idea of advisories means that every individual technology is like, yes, I know how to categorize a malicious activity, but they all have completely different identification systems for what is bad action, or how to even categorize bad activity when it comes to skills. So yeah, malicious packages is much the same idea, which is really exciting. So in this case, yes, we are exclusively using the mal-dash system, but this is not, as Amir says, the only system that exists today. So here's an example of where we're filtering it down and we're just checking for starts with mal-dash. That removes all those GHSA examples for, yes, there's aliases associated, GitHub security advisories, but we're focused purely on tell me if there's malicious package in, for instance, Axios. That is the example. So we're doing this example here of just doing manual curls, but as Manfred says, this is not a very effective system when you have thousands of dependencies in an application. So what we're doing is we're using Snap, the package manager here on this VM, just to install OSV Scanner, which is an open source technology in itself. So that takes 2 moments. We see we've successfully downloaded it. And I have a requirements.txt file. So I could cat the requirements file, cat requirements, sorry. And you can see it's really simple. It has 3 dependencies on specific versions. So there's light LLM, pandas, and requests. Now, if I were to scan that, requirements.txt file, you get this output, which tells you much better than what we just saw there a second ago, which is here are the packages, the version of them, in what file was scanned. And here are, for instance, the vulnerabilities associated with, like the CVSS, the score that's assigned to those vulnerabilities. Now, in the case of the PySec advisory, the one that has the malicious package in light LLM, we can just click into that view and then we can see, okay, in osv.dev inside the vulnerability database, here's all the associated information, or we can query that API like we mentioned a while ago. But right now we have a category, a grid view of here are all the things, the 3 dependencies that exist in that requirements file, and we found malware in it or malicious code. Now, what happens if I take an enterprise technology? I talked through this example the other day amongst Manfred and Amir, but you might be able to guess already what platform this might be. But we're using a platform stack, so like you imagine all of these self-serve template technologies that are open source. Imagine how many software dependencies exist in one of those. So when I ran this, I pull the lock file, the yarn.lock of that enterprise technology, again, open source. I scan it. So you can see here, when I scan that lock file, I have 4,253 packages. Now that's outrageous. The idea of manually sieving through dependencies in something that big would take you probably weeks of your time, so you're not going to do that. So we put the lock file through the yarn.lock, and your first task is to find the answer of which package in here is malicious. Now, users might have already got this answer and have since moved on. I'm going to pose the question to Amir and to Manfred. Can you spot the malicious package here inside this lock file?
I can see some tech docs one.
Yes.
It has a weird
funny enough, yeah, it's not the only one. Funny enough, I actually had to make sure this question supported multi-answer. We can see the Yarn plugin backstage, as well as the tech docs. And I found another one actually earlier today, which was, correct me if I'm wrong, at the top here somewhere. It's really hard when you look at it to the naked eye. But if I was to maybe run that previous script and grep it for mal, then we'll give it a few moments, because again, we still have to sift through 2,500 dependencies. But when we give it a few seconds, we should see a grep, a filtered down output for anything that starts with mal-dash. And actually, we should have 3 dependencies with 4 total advisories. So there was definitely the tech doc CLI embedded app, a Yarn plugin backstage, as well as an example backend. So again, quite a funny way, to first application to have scanned and to have found not 1, but 3 malicious dependencies. So in this case,
does highlight something really important as well, doesn't it, Nigel?
Yes, that anyone
there's always
can
going to be malicious packages, right? You're going to try and find them, and you may think there's one, but once you start looking into things and looking into the details, you're often surprised, right? Like we are here.
Exactly. And again, the point here is like, this is not about people doing bad things. I'm not saying that. I mean, obviously, adversaries are pushing bad code to public registries. That's a fact. But as far as how we consume it, we are working with a system of trust, which is building open source applications, full scale applications, I'm going to use the request library. I'm going to use the Axios library. I'm going to use different plugins because they exist and they've been built. That's the foundation of open source. But me having blind trust and choosing to use a trusted dependency, you know, I may have now distributed bad code to other users who then use that application. And it's not that they're silly for trusting. We all have a system based on trust. I think we're just saying here, but verify it first. And by running it through something like this scanner, we can see actually there is some bad code potentially inside this very trustworthy open source technology. So running the script, the first capture the flag is actually any one of these answers. So not the mal dash, but the actual package name would be your answer. So pasting in our answer, we can see that it was, you get the reward. You're allowed to move forward to task number 2. So
amazingly enough, this is also like, that's one of those things where it's very critical to understand your dependencies, right? Like any application you write, you just insert like one dependencies, but especially in the JavaScript ecosystem, but also others, the dependency tree. So what you actually depend on is always way deeper, and tools like that really help you understand. And I think it's kind of like one of the duties of a software engineer to understand the application that they're working on, at least to a large degree. And that means also understanding the dependency you use, not just the code you write or your AI tool now writes, right? Like, so it's a big task.
100%. And it also goes to show from an operational perspective that we're not doing these as one-off manual tasks. Like, we're not spending our time hunting malicious packages. That's not how any organization should exist. So rather than doing it that way, we should find ways, creative ways to integrate these technologies into our pipeline. For instance, when we do a build, we should naturally have scanning in place that would check us if there's something bad in build. Or if you've already done your build and you've put it into runtime, which is Kubernetes or some other interesting runtime, you want to also be able to say, is it good even after it was shipped? So in this second activity, what we're doing is kind of looking at that, which is, hey, look, I can kubectl and check all my pods in my cluster. I have some interesting stuff. Well, it's actually not interesting at all. It's a generic environment. I got Gatekeeper. That's not even doing anything. I have some kube system pods that have to exist. And I've introduced one simple Python generic application with my own Docker image that's coming from Cloudsmith. So that's it. It's really just Python latest, but it's sourced from my own private registry. So if we try to apply, you can see that it's already running. So as long as you've made sure that your pod is running, let's see if we can apply that OSV logic of malicious packages to a actual active running workload in Kubernetes. So in this case, I'm going to export, it's just an environmental variable label, but app. So in this case, what we're doing is we're basically saying, can you list the pods that have that label, the app label? Then I'm going to do a kubectl exec against that pod and list what are the Python packages that exist inside that pod. So in this case, pip gives me back like 5 responses saying you've got requests, you've got IDNA, that kind of stuff certified. This exists by default in a generic Python image that come off Docker Hub,
That's going to be just that first one, right? Like the default namespace Python app. Like the other, like you basically are reporting out of that container, not any others, essentially.
100%, exactly. We're focused purely on the app equals Python app, labeled pod inside our Kubernetes cluster. But you can imagine in a real production environment, lots of pods, absolutely a lot more packages that are showing up inside them. So what I'm doing here, and this might look ugly, but it makes sense, is I'm fabricating, I'm acting as either the bad guy or as the AI in this case, which is to create a fake dependency name that really doesn't exist. So we'll show it now in a second. I'm basically going to do kubectl, running that against the pod that had that special app label, environmental variable. I'm shelling into that container and I'm listing with pip what's inside it. And naturally, you can see that a new thing has been added, which is requests. Now, we all know requests, the legitimate dependency that most of the internet's kind of using, but I've added one with 2 T's. Now, this might sound really stupid, like why are you adding a fake fabricated package name into a running pod? But the reason for it is that OSV technology we mentioned could be used in edge cases. So I put together a very simple Python script, and this Python script is using that API, but scanning it against running pod. So in this case, I can run Python 3, run the OSV Python.py thing, whatever it's called, and run it against a specific network namespace. As we mentioned, our Python application sits in the default network namespace. So I'm just going to run it like that. And what it's doing is, again, this is a custom script, but it's going to scan what are the dependencies. And sure enough, it says, I found malicious code inside a running container. Now, this is so powerful because as opposed to our very bizarrely reactive thing we were doing earlier, which was checking things after they maybe already, before we installed them, this thing is already running with bad code in it. So we're proving that we can scan it. Generally speaking, organizations won't use it in this way because, again, the damage is done. The container's running, and we're assuming here that that's fabricated dependency that does now turn out to be typosquatted, and it potentially contains bad, like payload executes a crypto mining malware. It's a bit late. It's already running exemrig, mining my resources on my Kubernetes cluster, which is a great target for this kind of activity. I'm already a victim. So we would want to move something like OSV scanning. While it's cool to do it this way, we want to move it earlier into the CI/CD pipeline to make sure before we push a build. Go ahead. Sorry, Manfred.
Just scroll up for a sec, right? Like, if I understand it correctly, like you're simulating an attack as well, in the sense that you are shelling into that container, right? Like,
exactly. Like an attacker would do something like this, that they would shell in a container, introduce something at runtime, assuming they had access to your Kubernetes cluster that didn't exist in the original build. So that would be an example of, drift.
Yeah. So one thing that I wanted to point out that sort of like also shows that's important to understand that if your container doesn't have shell on it, then that's not going to work. Right. So
exactly.
Having minimal containers is like one really good protection. So don't run the standard containers that you get with package manager installed and shell and that kind of stuff in your production app if you can avoid it, right? Like use minimal containers that reduce that surface. That's one of the reasons why you want to do that.
Less possible things to be compromised, exactly. But sorry, Amir, you were going to say something there.
No, I was just going to say that the cornerstone of sort of solving this problem starts with discovery, right? If we look at all of what we've seen so far, until we've done a scan, understood the lay of the land, we can't do anything to fix the problems at hand. So this is why it's so important to understand the lay of the land when it comes to your applications. What are we using? Where are we using it? And what can we do about it, right?
Yeah.
And that's the exact same for AI too, right? And that's why SBOMs and AI-BOMs are super important when it comes to building out your applications and having the understanding of what's going on. Because until we know this, we're just acting oblivious, right? We don't know there's a malicious package mining crypto on our actual containers, right?
Yeah, 100%, exactly. Because I mean, they're getting smarter about it. Even the crypto miners, they often do it at like a low rate, right? Like they don't want to use too much of memory because that would get detected by someone who's
too obvious.
Unusual. It's too obvious, exactly. So I'm gonna mine just the tiniest bit of Monero, but I'm gonna do it in a long-lived workload over a 10-week period rather than
really
doing a lot of activity.
Passive income with that, right? Slowly but surely.
Exactly. To the point where it's almost not worth your time.
Exactly.
So, the next example of what we introduce into this environment is this. I think it's a really fun open source project. It's called SlopGate. I only saw this appear the other day on pip. So, you can run pip, you can show that your package exists, and, it's got an MIT license. So great. It's a full, you can do whatever you want with this. So I run SlopGate against the requirement.txt file we talked about earlier. And it tells me a bunch of, actually, this is a modified, I think, requirements.txt. Yeah, I've introduced a bunch of dependencies. So these ones you can see clearly typosquatted, fake package names, all that kind of stuff, purely for testing. And what SlopGate's telling me is it has the ability to block these packages, which is really cool, again, if we enforce this at the CI level. But what it's saying is name does not exist on one of those open source registries. So again, the likes of the NPM, in this case, would be PyPy, since it's a requirements.txt. And it's telling us it really does look a lot like request, which is a very popular, well-known package. So in this case, it kind of has that typo/slopsquat signature about it, which is it looks too similar, doesn't exist on the registry, think it may have fabricated that package name and it doesn't exist. So again, it's one other tool similar to OSV that can keep us ahead of the game, which is I don't want to introduce bad or fake package names into my environment. A scarier one that can show up,
isn't it, Nigel? When you look at it, right?
So
it's
easy.
So easy to make a typo and just pull in something that you didn't really want to pull in.
Yeah, I think some of the obvious ones that show up a lot are the ones like the Hugging Face CLIs of the world. That they're long enough a package name that in your head it sounds completely credible, where you say, Hugging Face dash CLI, yeah, that does sound like the correct package name. And sure enough, it that would be an example of something that might get type squatted, whereas requests, it really, a lot of it comes down to repetitive actions like typing something down really fast. And again, you see the example where you just dropped an S in request, or you thought it ends in an S, but it didn't, or whatever it be. So yeah, very easy to make this mistake. So with this tool, we're going.
It's kind of funny in a way, right? Like it's very easy to make the mistakes for humans and for eyes. And that's literally the only difference between typo and slop squatting. Like
I know the marvel situation of AI is a lot of people are like, oh, I used to make loads of mistakes, so now I've got this AI agent that's going to solve all my problems with grammatical errors, and all it's doing is making new grammatical errors, which is again,
Nigel, better mistakes.
Yeah, we all make mistakes, but AI makes mistakes too. So this last activity is actually pretty straightforward. I'm sure a lot of people probably completed it, but what I'm doing is I'm exporting the PyProject TOML to this kind of a beautiful way of doing it. Actually, is you can export it in different formats. So I chose to export it in slopgate.sarif. You can do the same with the skills tool. I'll talk about in a while. But basically, I have the Sarif output, which is like JSON structured, and it gives you all the details, which is really great if you're generating these reports and you want to show the stuff that's going on in your environment. But if I was to just run SlopGate, scan the PyProject without doing an output report, the question that's asked is, can you find the typosquatting requests? Now, in hindsight, this is rather simple, which is, look, we are using another custom script called exploit check. I'm checking the package in the PyPy registry for this typosquat. So what I'm doing is SlopGate's telling me that that thing is likely a typo. But what the exploit check then is doing is querying OSV, and sure enough, some attacker registered that bad code, we talked about earlier, the crypto miner malware, to the public registry, which in this case was PyPy, and it's got the malicious package advisory on it. So it's not just that, yeah, AI makes a mistake and it gave me a package name that turned out not to be a real one, but worse than that, some bad person out there filed that same typosquat package name to the registry, and I've now downloaded a crypto miner. That's a crazy thought. So, the
how
question
quick and easy
here
was that though, right? It was far too simple to have that within your code.
Too easy to run the scanner, the exploit check?
No, just having that appear within your actual code, right? Having the actual let's say malicious package. It's just so simple but so powerful when they are dropped.
Visually, there's no way of knowing that this is bad, because we go back to the issue, which is I scan requirements.txt. Unless you put these stupid, comments like real credible packages, no one has
this
that.
Is malicious. Avoid.
Yeah, do not download. So no one does that. So a real requirements.txt will just be a list of package with == version, and that's just really hard to read. And when you start, we talked about earlier the lock file with the 2000 dependencies and transitive dependencies and all that relationship, for sure you cannot credibly read this stuff. So we need to have automated technologies in place to tell us when typosquat exists, but if the AI is not just fabricating, but it's actually suggesting a package from somewhere in its learning data, which turns out to be malware. And that's a real thing that happens. Attackers get smarter, they start promoting fake packages on things like Reddit, that ends up in the learning data. Then the AI says, yeah, I've heard of this package, it's totally normal. And then it suggests you malware, which is such a crazy thought process that, the AI is bullied into giving the wrong answer. So
garbage
of course you
garbage out, right? It's learning
exactly. It's learning off a scary, dangerous internet. So in this case, you can curl the package name like we talked about earlier. But if you're confident you know your answer, which I think we do now, you can go up here, grab your malicious package ID, and paste it into the script. And sure enough, granted access to move on to task number 3. So I think we're still in very good time. We're about halfway through the capture the flag, though I feel like someone in the chat may have completed all the tasks. And if they have, congratulations. If there's people that are still only catching up with ourselves, then great. I hope this is a really beneficial learning experience. But where we are right now is we've basically just used technologies like OSV scanner, SlopGate, things to tell us this is a cryptography package that's a typosquat, something like that. So
Nigel,
really,
we have a question
yeah.
in the chat about how they can restart the terminal. I think Daniel's has crashed.
Oh, there should be a little refresh icon. Do you see this? And if you just click on that, it should just refresh the whole thing. The only reason I could think of is if like we were having issues with resources or something, but so far all we've been doing is downloading text files. So there shouldn't be any issues with resources in the lab, but let me know if that's not working. Again, a hard reset, you might do like a refresh on the URL, and it shouldn't kill anything, by the way. Like I've done this a lot of times. So, you know, all the files should still exist in that VM. So let me know if that works. It's just a hard refresh.
I just also wanted to point something out. Can you show that dependency list again?
Which one? Sorry. Oh, yeah, sorry. When we cat the requirements. Yeah.
Yeah, that one. So one thing that's interesting is like you're having requests equals, right? So that's nailed dependencies specific to a version.
Yeah.
Especially in JavaScript, but also in Python, you can have ranges. And then often upstream, and that's the funny thing, is even if you nail it down, upstream packages that you depend on might have ranges. And what that can result is in that you don't know that a transitive dependencies at a certain time pulls in a malware. So it can be like not as obvious. Like your requirements TXT might not have any indication of a typosquatted malware or anything like that, but you would still potentially be a victim to it in your app. So it's
funny, like
sometimes.
I was only reporting on Mastra incident yesterday, the NPM package, bunch of Mastra packages compromised in the NPM registry. And it was the same thing. They were doing, you know, that sort of range. And that meant people were impacted across, like, because they weren't tied down to specific pinned versions. So absolutely, there's lots of fantastic ways to also get in trouble when it comes to pulling packages. Yeah.
Sometimes I think it's worth not doing that. Like it's kind of interesting in the Java ecosystem. That's like, as a Maven developer myself, that's not a thing. Like there's support for ranges, but no one uses ranges. In the Python and JavaScript system, people do use ranges, but sometimes I feel like maybe it would be better if everyone logs the version and then use something like Renovate from end to just constantly update, but each time you upgrade, it stays locked to that version. And you have a better understanding, right? So you have that combination of like rapid improvements, but not dynamically out of control, but like knowingly, right? So,
of course, it makes complete sense. But just with the conscious of the time there, we're just going to move a little bit faster. Don't want anyone feeling like they miss anything. We're just downloading a tool called Sift. I have no personal preference. You know, you can use whatever technology you want to generate software bill of material, but this is just the tool I'm using. It's open source. So we're using Sift, and that TXT file I mentioned there a while ago with the package names, you can see it above. I'm going to output that into an SBOM in CycloneDX format. So the file is going to be called sbom.cdx.json. And again, as I say, the format is CycloneDX. When it comes to SBOMs, there's really two formats. There's CycloneDX and there's SPDX. If I'm correct, CycloneDX is the OWASP Foundation. And when it comes to SPDX, we're talking Linux Foundation. Anyone can correct me if I'm wrong, but I'm pretty certain I'm right. So this is how it would look. We've generated the output. So if I was actually to cat the SBOM, it looks like this, which is, well, what am I supposed to do with that? That's a lot of information, and it's totally not readable. So you would actually use something like JQ to JSON query it in, I think that's correct, JSON query, but pretty print it into JSON structured output, which is, wow, okay, that little thing that had like 6 packages mentioned in it, this is the output. That's pretty long, actually. So, you know, that is what SBOM's doing. So what SBOM is essentially saying is I scan something like the requirements.txt, which is what you generate the SBOM based on. And it's telling us all the dependencies, things like, say, for instance, TensorFlow, which is a dependency we mentioned, but also things like the transitive relationships between those dependencies. So that is a really fantastic thing that we're able to generate. And again, you think information like the package ID, the unique information in this sort of BOM, bill of material reference for those. So I know I'm moving a little bit quick through this, but again, please take your time. When you want to go back to this lab, you absolutely can go through these technologies and really get a feel for them. But what I'm doing here is I'm downloading a tool called BOMCTL. Also, it's under the OpenSSF Foundation. Again, all these technologies are open source. So what I'm able to do is I can fetch these files, like for instance, a specific SBOM. I can also export them into whatever format I want. So I mentioned there, like Cyclone DX. Now I have my SBOM.json. So you can jQuery it. I can say, for instance, use head to look at the first 10 lines. And you can see that the SBOM comes out in, Cyclone DX format. If you want to read the full thing, just remove the head from it. But if I were to export said report into a new file called mysbom2, and this time format into SPDX, naturally now I have an SPDX report. So this, what we're talking about, is standardized tooling, standardized formats, whichever one you want to go down. They're pretty much the same idea. Do recommend just kind of getting a feel for like which one you want to look at, but I have no strong preference over either or. The point here is that with OSV scanner, you can then scan said bill of material and naturally get the report we saw there a while ago, which is I'm now scanning the bill of material and it's telling me, do I have, for instance, known vulnerabilities, malicious packages, that kind of stuff in it. But when you see the packages and the relationship between those and its associated transitive dependencies, which are subject to change, that's the true way of knowing what the heck is in this application. So when we have now AI agents, they have to have their own bill of material, which is AI-BOM. So here I'm going to give a very simple example. Maybe people have already figured out this, but what I'm doing is the OWASP Foundation have their AI-BOM generator. It actually exists in a Hugging Face hub space, which is pretty darn cool for those who use Hugging Face. So I can grab the McPotato, which is the host, I guess, the user, and their database, the AIDN model is called 42 iCar Street. So I can paste this into here, or I can do it via CLI, whichever works. And you can see it's coming out in that Cyclone DX format we talked about a while ago. There's really two versions, 1.6 and 1.7. And it doesn't really matter right now, but basically it's telling me how good is this model from a completeness, like what things are missing. They have concepts of like model cards, that's the associated information that exists on the hub. But it basically saying like what information is fed into that model, into the AI-BOM. So there's a lot of information that's missing. But what we're doing in this task here is basically using the AI-BOM as our way of understanding external references. For instance, not just the author, like who created it, but where did they create it? Like, was it created in Hugging Face, the world-renowned single registry for all things AI model? Or is it hosted somewhere else? Like, it could be on a website that was not huggingface.com. That is a real reality. So in this case, yes, great. It came from the actual Hugging Face. We can see the version on it, like when it was published, that kind of thing, or even just when this AI-BOM was generated, that kind of information, because again, it's a historical reference of what's going on. So what we're doing in this simple task was actually just to find, well, can you identify in capture flag 3, can you identify a secret exposure? So sensitive credentials exposed as part of the AI model. And you might be thinking, why does AI model have sensitive credentials? Well, actually, you can go here, go to the distribution. So what are the model files? So if I was to grab this URL, which is showing me the main directory for that model, I can just paste this in, go to it. Oh, yeah, that should work. And yeah, here we are. So you can see McPotato, 42 iCar Street. First of all, this model is categorized as not very safe. But going through the files, you can see certain files like pickle files are considered bad because of the idea of deserialization, which means they could run arbitrary code execution. Not great. But the actual exposed token is inside here. So which means random YAML files, text files, stuff like that could get wrapped up and published to the hub. So in this case, a user absolutely could expose a GitHub token or something else to that extent in the hub. So for the last task, you can absolutely just run question 3, go to the hub. I hope I explained this well enough, and grab that token and paste it in here. And sure enough, you should have the right answer. But if you're unsure about it, what you can do is use a technology like, say, for instance, TruffleHog, which generally tells you, for instance, you're on GitHub or whatever, if sensitive credentials are being exposed, secrets, that kind of stuff, passwords. So in this case, I could use TruffleHog, use the Hugging Face integration, and just scan the model. And sure enough, it would tell you, yeah, you have Hugging Face credentials and you have GitHub plain credentials, and they are absolutely exposed. And when it was published by Luke Jorge, I guess is how you pronounce his name. But yeah, he definitely published this GitHub personal access token. So you have the right answer. You are ready to move on to the final task. So we're still moving in good time. Is there anything you want to add on that, either Manfred or Amir just on the idea of publicly exposing credentials and why that's a terrible idea.
It kind of reads off the room itself, doesn't it? As in, you should not be doing that anyway on a good day. But what I wanted to add is that the similarities between the model detection and the third-party library detection, it's so similar, right? We seem to think, oh, AI has introduced a new problem. It hasn't. It's introduced the same problem, just with another technology. So when we're looking at these AI bills of materials, it's basically just your software bit of materials, but just for the models that you're using. And again, that comes down to discovery. If you can't discover the problems, how can you fix them? Whether it's the hard-coded credentials, whether it's the actual model files being vulnerable, you need to know what you're doing and what the actual models are doing inside as well, right? So visibility is the first part.
Yeah. Like one of the things I noticed earlier is like one of the models had, for instance, you can see here like a notebook, you know, like Juniper notebook type technologies. And again, it's the same thing. They're importing libraries, and these are, I mean, this is deliberately done, but vulnerable libraries, or for instance, pushing personally identifiable information in here and API keys and secrets and stuff like that, just to see, does it actually notify us when we're pushing things that should naturally not be inside our application, which is you shouldn't have a model with associated risky formats like even Python categorize it as that, you know, the pickle format, pickle, Python. You'll actually, if you go to their documentation, they'll absolutely tell you something to the extent of, warning, pickle is not secure. You know, do not use this if you can otherwise avoid it, you know? So when it comes to AI models, yeah, a lot of these AI engineers are going to use pickle as a format because it works. It's an object serialization and deserialization, so you can, you know, run things. But like when it came to actually Hugging Face Hub, they eventually said, yeah, we've got to come up with a whole new format to solve this problem. And they came up with safe tensors, which essentially just became a read-only object. And that way avoided this issue of people just randomly deserializing or executing arbitrary code when they do the unpickling, which is, yeah, pretty darn scary. And again, people don't know any better. So we now need to scan models much the same way we do with other things in our stack. So this last task is a really fun one. I think Manfred said at the start of the session that, you know, even Chainguard are thinking about this problem, which is scanning skills. So for those who don't know, agents that do all this autonomous agentic stuff, you know, automated tasks, they have to be given instructions, and those instructions are skills, these .md files. So when I run Caterpillar scan, it's checking my environment and it's saying, yeah, I mean, like everything looks good, because it should, right? We haven't done anything with skills yet in this environment. I just have my exploit check and some other, I think I had a skill file sitting around, but I wasn't doing anything with it. But they're all fine. It's got a good confidence that everything's safe. Now, what I've done is I've put, actually, no, I'm taking this from awesome OpenClaw skills. So there's a public registry of all these random .md files, markdown files. And these markdown files, as you can imagine, are just text files with a set of instructions on what to do. So you might look at this and go, yeah, but how are those malicious? You know, they're just markdown files. So what I'm doing is I'm downloading text files, running them through Caterpillar, and Caterpillar is telling me, yeah, I mean, it's got environmental secret access. That's a bit strange. Would you want to give it that much permission to your agent? I mean, you can, but it's considered a high risky thing. Now, if we went down further and you downloaded, again, more markdown files, so I could download a mock malicious workflow thing that I've put on my own GitHub project. I scan it through, and then it starts saying, okay, now you're getting like an F rating, which is saying things like AWS credential access, SSH key access. If you're giving it root access on your agent and then telling it via these instructions what it can and can't access, of course it may be able to read environmental variables and other objects that exist on your local workstation. Pretty darn scary, right? Which is, people want to do automation. They also trust people who know a load about agentic, and they take their skill files and they apply them to their agents. But what are those agents able to do? So, you know, the further we go down the rabbit hole, we realize some of these skills are really scary. Like this one's so bad, it didn't even get a score in confidence. You know, it is just doing everything wrong. There's like shell execution and credential access and all sorts of things. So what we're doing next is, to the point of both Amir and Manfred, there's no standardized industry approach to malicious package, let alone to skills, which is we're all coming with, you know, interesting, exciting ways to solve the problem. One of them that may become a standardized type of open source technology, for now at least, is SkillSpectre. So NVIDIA, they put up a technical blog and they said, look, actually in hindsight, a lot of these skills are pretty darn scary. And the last thing you want to do from a governance perspective is give an agent too much permissions to do things in your environment. That just seems like a fair and honest thing to do. So what they did is they published this technology, SkillSpectre. So what I'm doing here, I know I could have probably pre-built this before we joined the session, but it might take you 40 seconds or so to do it. But basically, we're git cloning SkillSpectre from the open source project from NVIDIA. In the directory, then we're building it with Docker. Again, once built, what we're going to do then is take those two skill files, those markdown files we saw a second ago, which told us, yeah, you got an F rating of 0 out of 100 and you got an F rating of 25 out of 100. So in both cases, the markdown files were considered critical, but the findings are ultimately going to be different. So yeah, in this case, we found things like credential access, SSH key access, the ability to run shell patterns, being able to, like Manfred mentioned earlier, terminal shell into container, that kind of stuff. In theory, the agent absolutely could execute those actions. So what we're doing is we cd back out into our local directory, run Docker. So basically, I'm just running in that the file there to scan it. Now, actually, this one doesn't do anything. This is just to show you, if you just scan the local directory, nothing would show up because naturally nothing was there to scan. So what we're doing is we're making a directory called myskill specifically. You can see here I'm moving the mv command, those two markdown files we had earlier, into the myskill directory and then running it again. Now, the reason I'm doing this with the --no-llm is I'm basically not checking an API key for any of the common LLM technologies. I'm just scanning a markdown in a local directory. And sure enough, the responses are kind of the same. We're seeing things like reverse shell. We're obviously seeing the two files, but there's things like confidence rating per what they call, I don't even know what you want to call these, but like the tagging for the behavior, a bit like the way you might have OWASP top 10, you have your controls. These are essentially controls. Like there's a Yara 1, which is categorized as reverse shell. I'm sure there's a bunch of different Yara rules that are applied through this. So definitely SkillSpectre seems like it's giving us a little bit more of a verbose output, which is like, okay, I can see the two markdowns, they're categorized markdown, and it's giving me score on the lines, within the file that is scanned. And of course, this is critical activity. In fact, recommendation, just don't install these, like it can't be any more, blunt with the user. So for this, so we ran that test and that worked. You could absolutely export the report, which is to say, export it to something like JSON, give it to a specific directory. Sure enough, I now have a scan directory, so you can scan the report. And again, even more verbose, which is things like, how would you remediate the issue? Tell me where in the code it found that flaw, so maybe I could fix it. Again, some of these are pretty, again, like we say, blunt, which is the Yara rule told me there's ability to do reverse shell. And inside it, it shows me the actual line of script that it's doing the reverse shell on, which is bash, the TCP, whatever connection trying to be established. That is quite literally put in the instructions on the shell file or on the markdown file. So what we're going to do is for the last activity, some people might have already completed it. There's a directory called suspicious skills. I know it's kind of self-explanatory, but there's a markdown file, a text file, and a scripts directory with another file inside it. Now, if we were to run that Docker run like we did earlier, but this time against that suspicious skill directory, we should get completely different outputs. So the last question, I know we're short on time, so I'm probably this really quick, but basically I want to output the file into a lovely report. So we get a report, the report comes into a specific report directory. I'm then going to run it through, so it's called vulnerabilities JSON. We cat that file. So basically we want to read the contents of the report. And the question is, can you find the confidence rating of a potential memory poisoning attack? Now, going in here, we can see all sorts of information about vulnerable supply chain issues, like, python.env on version 1.0.1. So definitely it's giving findings that we would associate with things like open source vulnerability scanner, which is, why are you recommending them to use vulnerable packages or even malicious packages for that matter? But the actual thing we're identifying is to see here, it's injecting a whole bunch of bizarre line breaks, BR, and putting in some information in here. So this is something like memory poisoning. Like, what if I started doing context window stuffing, like throwing a whole load of junk into the context window? that wouldn't be good from a memory perspective, even though a very simple example of doing so. So it was actually able to identify to give it a medium type risk because it doesn't know if that's actually exactly what they're doing, but at the same time, it got a confidence rating of 0.8. So to complete the capture the flag, you just need to run the final question. It's asking, could you find the confidence rating? And it was 0.8. And that kind of brings us to the end of the exercise. As we mentioned, it probably isn't the most complicated assessment we've ever done as far as capture flag, but I hope it was an educational one as far as being able to prove, as Amir mentioned earlier, and same with Manfred, that this is just a new interpretation or new level of the same thing we were already doing, which is we should be scanning files, we should centrally control them, and we should have some level of governance on what we do and don't allow inside an organization. And the same rules apply to something like skills. So with that, I'm going to jump back into our slide deck. I'm just going to kind of close it out here by saying, look, we have a newsletter if anyone wants to see updating news, all things related to supply chain attacks. We'd be more than happy to keep publishing that and to share the news with yourselves. I'm going to hand it over to Amir if there's anything you'd like to add here as we're on our closing notes.
Thank you so much, Nigel. Yeah, we obviously know how AI is impacting application security in general, right? So we've got a fantastic webinar that is going to be out next week. So definitely sign up to listen to that one. It's going to be a fantastic one. But also we're going to be at OWASP Global AppSec in Vienna. So if you're down there, come say hello, get some free swag, and see what we can do to help you at Mend.
Amazing. And if there's anything you wanted to add there, Manfred?
Yeah, I just wanted to mention that the agent skill example was really exciting. It pointed out all the issues. What we now do in our new Chainguard agentic agent skills is we fix the skills. Like we provide a bunch of those upstream skills and we harden them. So you get access to the skill and a hardened file that tells you what was actually done to remove those issues. And that's available for free. Next week, we have what we call AI Readiness Innovation Week. We have a whole bunch of announcements around our products. We have the AI Tech Talks and the AMA with Dan Lawrence, our CEO, around the whole mythos and our new Athena initiative that is an industry-wide initiative. So there's a lot going on. So it should be super exciting next week.
Amazing. And I'm just going to, I don't know how we do this normally, the drum roll. I'll just leave these open just in case anyone is actually planning on being at PlatformCon next week. If you're actually not planning on being at PlatformCon next week, we're also doing a bunch of virtual workshops. They're all free to attend, and they cover all the similar topics we were doing right now, which is hunting malicious packages, identifying malicious skills, agents, and how they apply to platforms. It's all pretty fun stuff, in my opinion. But the winner, and I don't have a slide dedicated to this, but I hope they're still on the conversation, completed in 32 minutes, which is the fastest time without any backdoor cheats or anything like that, is Kieran Raj. So I don't know if Kieran is on the chat or if they want to put themselves into chat to say they're still here. But either way, we will contact you as the winner of today's activity, and we'll send you an email with instructions. I don't know, Claire, if you want to add anything on that, which is how we notify the winner that they've won.
Yeah, congratulations, Kieran. I don't know whether I saw a thumbs up there, but I'm not sure whether that was the winner.
Yeah, he had chimed in the chat. So congratulations.
Okay.
Well done.
Well done, Kieran.
And there you are, Kieran. Perfect. I was going to say, are you a Kieran with a K or a Kieran with a C? So that helps. Thank you. Congratulations. Yeah, Kieran, just make sure that you put your email address, your correct email address, so that I can contact you directly, get your address, get everything sorted out, and we'll send your Raspberry Pi 5 to you then. Congrats. 32 minutes, that's fast. So you've
amazing.
Thanks for holding on as well to the end.
Listening to us rambling. But yeah, I hope this was a really beneficial session to everyone attending. For context, the times after were really, really close. So the winning time was 32:16, then there was 34:12, 35:39, 36:39, 30 or 47 in 2 seconds, and then 48 minutes and 24 seconds. So my point is there's only like a minute between all of the people who came in. So it looks like everyone completed all their tasks, and of course, I hope that there was a good learning experience here.
Yeah, exciting. Well done.
Yeah, so with that, I guess we'll wrap up, Claire, and thank you everyone for attending today's session, and congratulations, Kieran, on the fastest time.
Thanks so much, everyone.
Thanks, everyone.
Have a lovely day. Bye for now.
Bye then.